Welcome back. Okay, so this time what we're going to be talking about are even and odd numbers. And you'll remember throughout the week we've talked about all these different ways to identify even and odd numbers. And as teachers, we found out about a little trick where you can take your hand, and you can follow me while you do this. You put your finger down here on the bottom of your thumb and you start counting. And you start here with 0 because there's nothing there, there's 0. 0 is the first even number. Then at the fingertip, this is 1. 1 is the first odd number. Come down to the inner loop right here and you have 2. And 2 is an even number. And watch, the next one's going to be what? Odd, you guessed it. Odd is 3. Then we go down again. Even is 4. Odd, 5. Even, 6. Odd, 7. Even, 8. Odd, 9. And what do you think is going to be over here? 10, the next even number. So you can remember some of your even and odd numbers by remembering that if you press at the bottom of your finger, these are the evens, right? There's an even space here, 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 and here. Let's count by 2s. 0. Why did I start at 0? Because all numbers start at 0, right? So 0, 2, 4, 6, 8, and our last one, 10. All even numbers. Let's count just our odd numbers. 1. Why did I start at 1? Because there is no number that starts at 0 that's an odd number. A 0 is an even number. So we start here for our odd numbers. 1, 3, 5, 7, 9. So each of these numbers on our fingertips, 1, 3, 5, 7, 9, they are all our odd numbers. Our even numbers are on the outside. 0, 2, 4, 6, 8, 10. All right, now let's take a look at a few examples. You can see that there are 8 squares drawn here on this board. And what we'll do is we are going to separate them into 2 equal groups to prove that 8 is an even number. So the first thing I'll do is I will take 4 of these right here and I'll drop them over here on the left. Here we go. Then I'm going to take 4 more of these and I'm going to drop them over here on the right. Here we go. That means there's still 8 squares. So what we've shown earlier this week is that we can break up objects into 2 equal groups, and then we can write an equation that matches to prove that our number, our total, is an even number. Now we already know that the total is 8. So we have proven already by showing that we can put it into 2 groups, that this number 8 is even. But how do we prove it with an equation? Well, we take the numbers, our 2 add-ins, 4 and 4. That's what we call the numbers that we add together, add-ins. Add-ins are those factors that you're adding to get your sum. Okay, so 4 plus 4 is equal to 8. And remember, what we talked about was that if you have a doubles equation, then you have an even number. Doubles equations prove that your number, the sum, is an even number. You could make these groups right here. You could make groups of 2. And if you have groups of 2, well, that's going to give you a different kind of doubles, okay? In this case, you are going to have the equation 2 plus 2 plus 2 plus 2 is equal to 8. Now this is not the equation that proves that the number 8 is doubles. These are a form of doubles, and they do show with the pictures and prove with the pictures. Listen to what I'm saying. They prove with the pictures that 8 is an even number. But if you want to prove that 8 is an even number by showing an equation, you have to use the other format. If you don't use this format right here, if you don't use that equation up there, that doubles equation, then you are not proving with an equation that 8 is an even number. This is your proof right here. You have to use the doubles equation. So then what is this equation down here? Well, this equation just shows you that you can break it up into equal groups of 2. These 2's that you can break it up into, oops, trying to make another circle there. There we go. These 2's that you can break it up into, they're all shown right here. There's 2, there's 2, there's 2, there's 2. Let's check and see how many of those groups there are. 1, 2, 3, 4. So if there are groups of 2 and there's 4 of them, then we have the number 8. And now let me say that a little differently. What if I was to rearrange these squares? What if I were to rearrange them, and I'm going to drop all this down into the corner. Whoop. And what we're going to do instead is we're going to show these 4 over here on the left and these 4 over here on the right. Again, we're getting back to the idea that you want to prove by using your doubles equation up here. Your doubles equation shows 4 and 4. Kind of looks like a face. Woohoo! All right, so we have down here no doubles equation. It doesn't prove that 8 is an even number. But our pictures prove that 8 is an even number because there's nothing odd. There's no extras. They're all groups of 2. It's very important. Up here, we have 2 groups. And this is how we prove with our picture again that we can make an equation that proves that 8 is an even number. So here's where we get our equation from. We take our 4, which is right there, and we take our second 4, which is right there, and we get our 8 total. And our 8 total, you can see, makes up that whole set, our whole group. And there's our 8. All right, let's wipe the board clean for one more quick example.
We're going to start with 1, 2, 3, 4, 5.
Triangles. And those 5 triangles, what we're going to do is we're going to try and put them into 2 equal groups. Let's see if we can do that. All right. Earlier this week, I showed you that I could take this same program and I could sit here and I could just start making my little square around it so you can see it as I count it up. So let's do that today. 1, 2. Okay, I still have 3 on the outside. So that means that I don't have 2 equal groups yet. All right. How about if I put 3 on the inside of that square? Do I have 2 equal groups? Are they equal? There's 3 on the inside and there's 2 on the outside. Is that equal? No. So right here, what we're proving is that we can't turn this into a doubles problem. You can't make this a doubles problem because the only options you have are
1 plus 4 equals 5. 2 plus 3 equals 5. 3 plus 2 equals 5. And 4 plus 1 equals 5.
Do you see a doubles problem there? I don't. What I see are a whole bunch of numbers that do not actually have the same, and what's that word that I said at the beginning? Addend. They don't have the same addend. So you can see that these addends are different when you compare them to their partner addend. So 1 is not the same as 4. 2 is not the same as 3. 3 is not the same as 2, and 4 is not the same as 1. Even though we still got the answer of 5, okay, for all of them, that just means that 5 is the total. Yeah, 5 is the total. But 5 is not even. Instead, what is it? It's an odd number. All right, so we looked at our even, we looked at our odd, we looked at a couple of different ways to do our addends and our equations, but we made sure that we've got to be careful when we're proving that a number is even, we have to have a doubles, right? So our doubles will always look like
2 plus 2, or 3 plus 3, or 4 plus 4. It's going to be the same number added to itself.
and you'll only have the two of them. So you might even have 16 plus 16 is equal to, does anybody know that one off the top of their head? I'll give you 5 seconds. Did anybody say 32? If you did, you got it right. 16 plus 16 is 32, and that's a doubles problem. That's a doubles equation. So that doubles equation proves that 32 is, that's right, an even number.
But what if I were to write that like this? 8 plus 8 plus 8 plus 8 equals 32. Which it does. If I take 4 8s and add them together, I still get 32.
You can see that 8 plus 8 is 16 right here, and 8 plus 8 is another 16. Well, if 16 plus 16 is 32, and 8 plus 8 is 16, and 8 plus 8 is 16, then 8 plus 8 plus 8 plus 8 is 32. Wow, that's a mouthful. All right? But that doesn't prove that 32 is an even number. The only problems that prove that a number is even are going to be these types of problems right here. And what do we call them? One more time. Doubles equations. Doubles equations are the only equations that prove that a number is even.